Welcome to Get Your FRQ On. This question is from the 2008 B exam. It's question 1 and it is calculator active. In the question stem we have two functions, and in part A of this question we are asked to find the area of the region R bounded between the graphs of both functions. We can tell that the two curves intersect at x equals 0 and x equals 9. If you set them equal to each other to find the points of intersection, this is what you get. And for all values of x between 0 and 9, the graph of the square root of x is greater than or equal to the graph of y equals x over 3. So the desired area would be given by the integral from 0 to 9 of square root of x minus x over 3 dx. And since this is a calculator active, we're going to let our calculator do this math for us, and that volume is 4.5. In part B of the question, we are asked to find the volume when R is rotated around the vertical line, x equals -1. And since we're rotating around a vertical line, we're going to integrate with respect to y, which means we have to take our functions and rewrite them as functions of y instead of functions of x. To do this, we have y equals the square root of x, which implies that x is y squared. And we have y equals 1/3 of x, which implies that x is equal to 3 times y. And then from here, we have to construct our two radius functions relative to our axis of revolution, x equals -1. And our big radius is made up of -1 minus whatever function is furthest away from this vertical line, which is the function x equals 3y. So our big radius function as a function of y is -1 minus 3y. And our little radius function is going to be -1 minus the function which is closest to this vertical line, which is the y squared function. So the function little r of y is -1 minus y squared, right? Which means that the volume of this solid, when r is rotated around the vertical line x equals -1, is given by pi times the integral from 0 to 3. Notice the bounds changed because we changed to integration with respect to y, of big R squared minus little r squared dy, which is the integral from pi times the integral from 0 to 3 of -1 minus 3y squared minus -1 minus y squared dy. And again, since this is a calculator active question, we're going to go ahead and let our calculator find this volume for us. Using our calculator to do this integral, we get a volume of 130.062. In part C of this question, we are given that cross sections taken perpendicular to the y-axis are squares, and we are asked to find the volume of that solid. Now, because these cross sections are being taken perpendicular to the y-axis, we again will integrate with respect to y, but now we need to find an appropriate area function. So the difference, the side of one of these squares, is just going to be the difference between the two functions, 3y minus y squared. And then the area of a square is you take the length of the side and you square it. So the volume that we're after here is the integral from 0 to 3 of 3y minus y squared dy. And again, it's a calculator active question, so we're going to let our calculator do the calculus here, and we get a volume of 8.1.